How are silicon transistors tested? Have you ever wondered how the first silicon transistors were tested back in the 1950s? This fascinating era marked a shift in technology, as silicon began to replace germanium due to its superior properties. Testing these new silicon transistors was essential to ensure they worked correctly and met the necessary specifications. To start, silicon transistors have three terminals: the emitter, base, and collector. They control the flow of electrical current, acting like a switch or amplifier. The testing process begins by checking how well the transistor can manage this current flow. One common method used in the 1950s was to treat the transistor's junctions like diodes. Since a transistor has two p-n junctions, engineers would use a multimeter set to diode test mode. This device applies a small voltage and measures the current flow through the junctions. A functioning silicon transistor typically shows a forward voltage drop of about 0.6 to 0.7 volts across each junction when forward biased, and no conduction when reverse biased. This confirms that the internal semiconductor layers are intact. For more detailed testing, engineers would apply specific voltages and currents to the terminals. They would measure the gain, leakage currents, and switching speed. During this time, specialized equipment was used to determine the current amplification factor, also known as beta. This factor indicates how much the transistor amplifies the input signal. Engineers also checked for leakage currents when the transistor was supposed to be off, ensuring it did not conduct unwanted current. Manufacturing silicon transistors was more challenging than germanium ones due to silicon's higher melting point and chemical reactivity. Therefore, testing was vital to identify defects that could occur during the diffusion process. This process involved introducing impurities into the silicon crystal to create the transistor's layers. Additionally, the surface quality was tested, especially after the development of a silicon dioxide layer on the silicon wafer. This oxide layer protected the transistor and improved its electrical characteristics, making its verification a key part of quality control. These tests ensured that silicon transistors could reliably be used in the new generation of electronic devices emerging in the 1950s, such as the first small and affordable transistor radios. These radios were some of the earliest consumer products to benefit from silicon technology, offering better performance and durability compared to earlier germanium models. In summary, testing silicon transistors in the 1950s involved simple diode-like junction tests alongside more complex measurements of amplification and leakage. This careful testing helped ensure that the new silicon devices met the demands of rapidly advancing electronics, marking a significant step forward in the world of technology.